Welcome to another deep dive.
Oh, yeah.
Today we're going to be exploring a concept you might not have heard of before.
Okay.
But trust me, it's lurking behind the scenes of so much of what you see and do every day. It's called Zipf's law, and it's all about these weird patterns that pop up everywhere.
Really?
From the words we use to the cities we live in.
Interesting.
To even like the internet.
Huh.
It's really kind of wild.
Okay.
So today we're going to deep dive on Zipf's law.
That sounds fun.
I'm joined by...
I'm an expert in weird patterns.
That's a good way to put it.
Yeah.
So let's jump right in. What is so fascinating to you about Zipf's law?
Well, what's in things that seem completely random. Once you understand it, you'll start noticing it everywhere.
Okay, so let's start with the basics. What exactly is Zipf's law?
So in the simplest terms, Zipf's law says that the most common thing in a set happens way more often than the second most common thing, which happens way more often than the third most common thing, and so on.
The bigger the difference in rank, the bigger the difference in frequency.
Okay, so it's not just that some things are more common. There's a specific relationship between how common they are and their ranking.
Right, it's not just random.
Okay.
The frequency is inversely proportional to the rank. So the thing ranked number 1 is going to appear about twice as often as the thing ranked number 2. 3 times as often as the thing ranked number 3, and so on.
I think I'm getting it, but I need a real-world example to really make it click.
Okay, sure.
What's something that follows this pattern?
Well, think about the words we use.
Yeah.
Some words like the of and appear constantly.
Yes.
Those are our top-ranked words.
Yeah.
Then you have words that are less frequent, and as you go down the list, they become rarer and rarer.
Right.
That's Zipf's law in action.
So what you're saying is even something as basic as the words we use follow this predictable pattern.
Exactly.
It's not just a random jumble.
Exactly. And what's even more fascinating is that the same pattern appears in all sorts of unexpected places. Okay, wait. You're telling me this goes beyond just words?
Oh, yeah.
Where else does this Zipf's law thing pop up?
Oh, you wouldn't believe it.
Okay.
We see it in city populations where the biggest city in a country is often twice as big as the second biggest.
Wow.
3 times as big as the third biggest, and so on.
So it's like those huge mega cities didn't just randomly become enormous. There's a pattern at play.
There's something else going on. And we see the same thing happening online. A handful of websites like Google or YouTube absolutely dominate internet traffic.
Yeah.
While millions of other sites are fighting for scraps.
It's kind of mind-blowing to think that something as complex as the internet follows this seemingly simple rule.
I know.
It makes you wonder what else this pattern applies to.
Well, hold on to your hat because it goes even deeper. We see it in biology, too.
Really?
Think about the distribution of species in an ecosystem.
Okay.
There are usually a few dominant species.
Right.
And many, many more that are much rarer.
Yeah.
It's a classic Zipfian distribution.
So whether it's the words we use, the cities we live in, the websites we visit,
Yes.
or even the ecosystems around us,
Yeah.
there's this underlying pattern of a few major players and a long tail of less common things.
You got it. And that's what makes Zipf's law so intriguing. It suggests that there's this hidden order, this underlying structure to seemingly chaotic systems.
Okay, so we've established that Zipf's law is everywhere.
It is.
But I have to ask, why do so many different things follow this pattern? What's the mechanism at play here?
That's the million-dollar question.
Yeah.
There's no single definitive answer, but there are several fascinating theories.
Okay.
One idea is that systems naturally tend towards efficiency.
Okay, break that down for me. What do you mean by efficiency in this context?
So think about language again.
Yeah.
A small number of common words do most of the heavy lifting in communication, while a vast vocabulary of rarer words adds nuance and specificity. This balance between simplicity and complexity makes language incredibly efficient.
So it's like those common words are the workhorses, and the rare words are the specialized tools you only pull out when you need them.
Exactly. And this same concept of efficiency can be applied to other systems.
Okay.
For example, in cities, a few major hubs might handle most of the economic activity, while smaller towns and villages provide specialized services or resources.
That makes sense, but it still seems kind of mysterious. Is there anything else that could explain this tendency towards Zipfian distributions?
Another intriguing theory is the idea of preferential attachment, also known as the rich get richer phenomenon.
Right.
This applies particularly to networks like cities or the internet.
So it's like how a popular website is more likely to get even more popular because people keep linking to it.
Precisely. Or think about a big city.
Yeah.
It attracts more people and resources, which further fuels its growth.
Right.
This creates a feedback loop that naturally leads to a few dominant entities and a long tail of smaller ones, the hallmark of a Zipfian distribution.
So it's not just that big cities are more attractive, it's that their size makes them more attractive, leading to this self-reinforcing pattern.
That's the idea, and this rich-get-richer dynamic might be one of the driving forces behind the patterns we see in so many different fields.
It's starting to feel like we're uncovering some kind of secret code of the universe here.
It's certainly a powerful concept, and what's really amazing is that even though we've been talking about this idea for a while now, there are still so many unanswered questions about Zipf's law.
Oh, you've got to be kidding me.
I know, right?
We've barely scratched the surface, and there are already mysteries. What kind of questions are we talking about here?
Well, for starters, is Zipf's law a fundamental law of nature, or is it just a statistical quirk?
Okay.
Is this something baked into the fabric of reality, or is it just a consequence of random processes?
Those are some big questions.
They are.
What else keeps researchers up at night when it comes to Zipf's law?
Well, there's this exponent in the mathematical formula for Zipf's law, usually represented by the letters S. It often ends up being close to the value of 1 in so many different applications. Why is that? Does that value hold some deeper meaning we just don't know?
Okay, I am officially hooked.
Good.
We're going to have to unpack all of that in part 2, but for now, I'm dying to know, what's the most mind-blowing thing about Zipf's law for you?
Oh.
What gets you really excited about it?
Well, for me, it's the sheer ubiquity of this pattern. The fact that it shows up in so many diverse systems, from the natural world to human creations, suggests that there might be something truly fundamental at play here.
Yeah.
It hints at a hidden order underlying the complexity we see all around us.
That's deep, and on that note, we're going to wrap up part 1 of our deep dive into Zipf's law. Stay tuned for part 2, where we'll delve even deeper into the mysteries and implications of this mind-blowing concept. See you soon.
Bye. Welcome back to our deep dive into Zipf's law.
I feel like we've only just scratched the surface of this fascinating concept. In part 1, we talked about how Zipf's law pops up everywhere, from language to cities to biology.
Yeah.
But I'm really curious to hear more about how this principle is actually being used in the real world.
Yeah, it's one thing to recognize a pattern, but the real magic happens when you can use that knowledge to solve problems and create new things. And that's precisely what's happening with Zipf's law. It's being applied in all sorts of fields to make systems more efficient and effective.
Okay, I'm all ears. Give me some examples of how Zipf's law is actually being put to work.
Let's start with something we all use every day, search engines, like Google.
Yeah.
Think about how many searches happen on Google every single day, millions upon millions.
Right.
And each of those searches involves sifting through an almost unimaginable amount of information.
I've never really thought about it, but that's a truly mind-boggling amount of data for Google to handle.
It is.
How do they make sense of it all?
Well, Zipf's law plays a key role. Search engines use this principle to optimize their search algorithms. They know that certain words and phrases are going to be searched for far more frequently than others.
So they can kind of predict what people are going to search for based on these patterns.
Exactly, and that allows them to make their searches faster and more efficient. For example, they can preload the results for common searches so that when you type in weather, you get an instant answer.
So Zipf's law is actually making my Google searches faster. I never would have guessed.
It's working behind the scenes all the time, and it's not just making things faster, it's also helping search engines deliver more relevant results.
Okay.
By understanding the relative frequency of different words, they can better understand the intent behind your search.
That's fascinating. So it's not just about spitting out any old website that has the words I typed in. It's about understanding the context and delivering results that are actually helpful.
Precisely. And this same principle extends to other areas of the internet, for example, content delivery networks, or CDNs. Use Zipf's law to distribute content across servers around the world more efficiently.
You mean the systems that help websites load faster, right?
Right. That's right. They strategically store copies of website data on multiple servers.
Yeah.
When you try to access a website, the CDN directs you to the server that's closest to you geographically.
Right.
And guess what helps them figure out which content to store where?
Zipf's law.
You got it. By understanding which content is most popular, they can make sure that the servers closest to the most users have the data they need.
Okay, I'm starting to see the pattern here. Zipf's law is like a secret weapon for optimization.
It is.
And I bet this applies to more than just the digital world, right?
You're absolutely right. Think about urban planning.
Right.
We mentioned earlier how city populations often follow Zipf's law.
Yeah.
Well, urban planners are using that knowledge to design more efficient and sustainable cities.
That sounds intriguing. How does Zipf's law help them plan cities?
Well, imagine you're an urban planner and you need to figure out where to invest in public transportation. Knowing that certain areas are going to have much higher population densities based on Zipf's law can help you prioritize where to build new subway lines or bus routes.
So they can anticipate where the most people are going to be and make sure the transportation infrastructure can handle it.
Exactly. It's all about using data and patterns to make smart decisions, and it goes beyond transportation.
Okay.
They can use Zipf's law to predict traffic flow plan, the placement of emergency services, allocate resources for things like waste management, and even predict where new development is most likely to occur.
Wow. So Zipf's law is like a crystal ball for urban planners. It helps them see into the future and create cities that work better for everyone.
It's a powerful tool, no doubt, and its applications go even further. Researchers are even using Zipf's law in biology.
Wait, seriously, how can a principle about word frequencies be relevant to something as complex as biology?
Remember how we talked about the balance between simplicity and complexity being a key aspect of Zipf's law?
Yes.
Well, biological systems exhibit that same balance. A small number of genes and proteins are responsible for essential functions that are common to all organisms.
Okay, that makes sense. But where does the complexity come in?
The complexity comes from the vast array of less common genes and proteins that contribute to the diversity and specialization we see in different species. So, just like with words, there are a few workhorses that handle the basics,
Yeah.
and a long tail of specialized elements that create the amazing variety of life.
So Zipf's law is giving biologists a new way to look at the building blocks of life.
Precisely. It helps them understand how organisms have evolved, how different species are related, and even how diseases work, for example, by analyzing the Zipfian distribution of genes. They might be able to identify genes that are more likely to be involved in certain diseases, leading to new diagnostic tools or treatments.
It's amazing how one simple concept can have such profound implications across so many different fields.
Yeah.
This deep dive just keeps getting more and more fascinating.
And we're not done yet in part 3. We're going to venture into some even more thought-provoking territory. We'll explore some of the philosophical and perhaps even metaphysical implications of Zipf's law. Get ready for things to get really deep.
Ooh, now you've really got my attention. I can't wait to see where this goes. See you in part 3. Welcome back to the final part of our deep dive into Zipf's law.
Oh, yeah.
We've covered a lot of ground from the basics of this weird and wonderful pattern to its applications in everything from search engines to biology.
It's been quite a journey.
It really has. And now, as promised, we're going to take things to a whole new level.
Okay.
Get ready to explore the deeper implications of Zipf's law, the stuff that makes you question the very nature of reality.
All right, let's do it.
Okay, I'm ready.
So it has been quite a journey, hasn't it? We've seen how this seemingly simple principle, this idea that a few things dominate while the rest trail behind, pops up in the most unexpected places. But what does it all mean? That's what we're going to try to unravel in this final part.
Okay, I'm officially intrigued. We're talking about the big questions here. Right? Stuff that keeps philosophers and scientists pondering late into the night.
Exactly. Remember how we talked about the ubiquity of Zipf's law? How it appears in so many diverse systems from the natural world to human creations?
Yeah, it's like this hidden code woven into the fabric of the universe.
That's a great way to put it. And that ubiquity, that sheer pervasiveness, raises some pretty profound questions.
Like what?
If this pattern is so fundamental, so deeply embedded in the structure of things, does it tell us something about the nature of reality itself?
Ooh, okay, we're going deep now. Are you suggesting that Zipf's law isn't just some random statistical fluke, but a reflection of some deeper truth about how the universe works?
Some scientists and philosophers believe that's exactly the case.
Really?
They argue that Zipf's law might be a manifestation of a deeper principle of organization, a sort of universal law of complexity, if you will.
A universal law of complexity, that sounds pretty grand. What would such a law even imply?
Well, it suggests that complex systems, whether they're biological, social, or technological, tend to self-organize in ways that reflect this underlying principle. They naturally gravitate towards these Zipfian distributions, where a few elements dominate and the rest follow in a predictable pattern.
So even in the midst of all the chaos and complexity we see in the world, there's this underlying order, this tendency towards these predictable patterns.
That's the idea, and it has some pretty mind-blowing implications for one thing. It suggests there might be limits to the diversity and complexity we can observe in the universe.
Wait, are you saying there are like cosmic limits to creativity and innovation?
Not necessarily, but it might suggest that there are certain patterns and structures that are more likely to emerge in complex systems.
Okay.
Think of it like this. Imagine you have a set of building blocks. You can arrange them in countless ways, but certain configurations are going to be more stable, more likely to occur naturally.
So even with infinite possibilities, there are certain paths that systems are more likely to follow. It's like the universe has a preference for certain types of order.
Exactly. And that preference, that tendency towards certain patterns, might be what we're seeing reflected in Zipf's law.
Okay, my brain is officially doing backflips, but I have to ask, if this universal law of complexity exists, what does it mean for us humans? Does it affect how we live, how we create, how we understand our place in the cosmos?
That's the ultimate question, isn't it? And it's one that each of us has to grapple with on our own terms. If we accept that there are certain patterns and structures that are more likely to emerge in complex systems, does that mean we're somehow limited in our choices and actions?
I mean, it's a little unsettling to think that we might be constrained by these invisible forces, that our creativity and free will might be bound by these universal laws.
It's a valid concern, but I think it's important to remember that these patterns, these laws, are descriptive, not prescriptive.
Mhm.
They tell us what is not what should be.
So it's not that these laws are dictating our every move, but rather that they're revealing the underlying tendencies of complex systems.
Precisely. And understanding those tendencies can be incredibly powerful. It allows us to see the world in a new light, to make predictions, to design more effective systems.
It's like we've been given this secret map, this hidden guide to navigating the complexities of the universe.
That's a beautiful way to put it. And as with any map, it doesn't dictate our destination, but it can help us understand the terrain, the paths that are most likely to lead us where we want to go.
This has been an incredible journey, a true deep dive into the heart of complexity. We've gone from word frequencies to city planning to the very nature of reality itself.
And I hope this exploration has left you with a sense of awe and wonder at the intricate patterns that connect everything in the universe.
It certainly has for me. I feel like I've gained a whole new perspective on the world, and I can't wait to see where this newfound knowledge takes me.
And that's the beauty of it all, isn't it? The journey of discovery never truly ends. There's always more to learn, more to explore, more to understand.
Well said. And on that note, we're going to wrap up our deep dive into Zipf's law. But remember, the exploration doesn't have to stop here. Keep questioning, keep seeking, keep your minds open to the wonders of the universe.
Until next time, fellow deep divers, keep exploring.